Hello people, I'm Bharat Acharya. Welcome to our new video. So in today's video we're going to learn D to A conversion and generate waveforms out of it. There is this typical question that comes in the exam, generate a triangular waveform. So we'll be doing that. Let's start. If you see in the previous video of A to D conversion, I've made you understand what is analog and what is digital. Please tell me, analog means it's some voltage. Digital means it's some data. So look here. This is your 8051. 8051 is a MUSI. Any processor works on data. So MUPI's processor's world is digital. The real world is analog. Suppose you want to play sound, or suppose you want to display a graph. You will send different data. The D to A converter will convert every data into voltage, give it to the display will make a graph out of it. You need a plus VREF, minus VREF, all this I've explained in the A to D conversion video. You need a start-off conversion which you can keep permanently as VCC, or you can give it yourself also if you want to just increase your programming overhead. This is a simple program, not really required, there's nothing extra that you're doing. So keep it VCC, that means permanently started. That means the moment you put any data, it will convert and give the output. Now, to display a staircase, this is how a staircase looks like. Now, forget that. First tell me, before this also we have done waveform programs. If you remember timer section of 8051, the program that we did for the timer section was for generating a square wave waveform. Do you remember that? Now, when you generate a square wave waveform, what do you do? This is how a square wave looks like. Now, for that you have to first send 0, then send 1, then again send 0, then send 1, put it in a loop with appropriate delays. That gives you a square wave or a rectangular wave or a spike. Now, square wave, rectangular wave and spike are binary waveforms. They can be produced by just sending zeros and ones. But a staircase needs lots of values, starting from 0, then 1, then 2, then 3, all the way up to FF. Are you understanding my point? Now, why do we need a D to A converter for this? Look here. You're going to send your values to a display. A display is like a CRO. What does a CRO do? You send it voltages. I repeat, you send it voltages. It makes a graph out of that voltage. Now, when you want to produce a square wave, you need 2 voltages. To produce 2 voltages, you don't need a D to A converter. Take any pin of 8051. All port lines are bit addressable. Take any port line, send a 0, send a 1 by set B and clear. 0 is 0 volts, 1 is 5 volts. So you are sending 2 different voltages, it will still make you a graph. Did you understand what I said? To produce a staircase, the CRO needs increasing voltages. I repeat, increasing voltages. Processor cannot give different voltages. What it can give is different data. So if you put that data into a D to A converter, bigger the value of data, bigger the value of voltage. Please tell me, did you understand? So as you go on increasing your value of data, the voltage will go on getting increasing. Go on incrementing the value of data and put a small delay. You will start seeing steps in the voltage, in the output. That's your program. The program is ridiculously simple. First, I am teaching you how to produce a staircase because it goes in this sequence. Excuse me. First produce a staircase, then smoothen it out by making a ramp, then put it in a bigger loop by making a sawtooth. Once you get all this, then we come to a main program of producing a triangular waveform. Yes, that one comes the most, but that doesn't mean that's the only possible question. There are other questions also that can come. So we are doing all of them, but keep in mind triangular one is the most important one. That's the reason why we are doing all this. Okay, now look here. So, to produce a staircase, what do you have to do? First, you will send 0, then you will send a 1, then you will send a 2, all the way up to FF. So that's your idea. Move A, hash 0, 0, so your first output is 0. Move it to port 1. So you send 0, 0, D to A converter will give the lowest voltage. So you got your lowest step. Now, you want to see the steps. That means after every output, you will call a delay and keep a delay that is visible. Okay. So about 120, 130 milliseconds. You may even keep a second, but then it will be very boring. Keep it in milliseconds, but keep it in high milliseconds, like 120, 130, 150 or 200 milliseconds. So 5 steps per second. That is good enough. That looks like a good staircase waveform. Anyway, so keep a delay, substantial delay. I'm sure you know how to write a delay program. We have written delay programs in the timer section programming video. So call a delay. Increment A. So first put that value P1. You can write this increment A after this also, doesn't matter. Increment A. So what is the value that you have sent out? 0. A has been incremented, has become 1. Call a delay. Put this procedure in a loop. Now for the looping condition that I have used is J and Z. Now what does J and Z stand for? Jump if not 0. I repeat, jump if not 0. Now for any normal processor, J and Z instruction works on the 0 flag. But in 8051 there is no 0 flag. J and Z works on A register. I repeat, on A register. So it will directly check the value of A. A was 0, but after putting out 0, you incremented it. So A has become 1. I've said jump if not 0. A is not 0. It will jump because it is 1. It will jump. Now you display 1. A will become 2. It will jump. You display 2. A will become 3. It will jump. You will display FE. A will become FF. It will jump. You will display FF. A will become 0. I have said jump if not 0, but A has become 0. Now it will not jump. It will break the loop and stop. That means your staircase will go from 0, 0 to FF and stop. That's exactly that you wanted. Now it may not always go from 0, 0 to FF. Your examiner may say, write a program to produce a staircase of 10 steps. Great. Do this with a count of 10. So either keep a count of 10 or just monitor A. It should go from 0 to 9. When it crosses 9, stop. Either way, do it the way you like. Also, you can play with this program. If you do this in practicals, you can play with this a lot. Instead of writing increment A once, write it twice. What will happen? Each time A will be incremented by 2 values. So your steps will be taller. Instead of increment, write add A comma hash 0, 5. You're adding a value of 5. The steps will be yet taller. Again, you can change the duration of the delay. The bigger the delay, the wider are your steps. Smaller the delay, the narrower are the steps. So you understand you can make your staircase very slanted or very vertical. Taller or shorter steps depends upon how many values you are incrementing A with, the incrementing factor. And the width, the wider and narrower steps depend upon how big a delay you are calling. But still, call a delay that is visible. Don't call a delay of 1 or 2 milliseconds. That will be too small, it will look like a ramp. So that automatically gets us to our next program. Our next program is display a ramp. What is a ramp? Again the same thing. 0, 0 to FF, but now it has to be smooth. For it to be smooth, you don't want those steps. Are you understanding what I'm saying? Now, how do you not see the steps? Simple, remove the delay. Now, don't be so fast. If you just remove the delay, I don't know whether you've done this in practicals or not. If you do it in practicals and just simply remove the delay, you will not get such a beautiful ramp. You will get something like this, which will be near vertical. Because get this clear, 8051 is sending the outputs. 8051 works at 12, it has an operating frequency of 12 megahertz. Even if you divide it by 12, it works at 1 megahertz. It does 1 million operations per second. Your 256 outputs will be out so fast that it will look near vertical. Put a delay, not a very big delay, 1, 2, 3, 4, 5 milliseconds. Again, this is all plain. Put a delay of 1 millisecond and see what happens. You will start seeing a slight slope. Put off 2 milliseconds, even more slanted. 3 milliseconds, more slanted. 4, 5, till the point you will start seeing it break. Once you start seeing it break, stop it, go one step back. So anything around, if you ask me from my experience, about 4 to 5 milliseconds gives you a nice slope on your ramp. If you don't put a delay at all, you will not see that. You will see near vertical. And if you put a very big delay, you will start seeing staircase. So keep a very small delay of 2, 3, 4 milliseconds. Even if you don't keep, this is also technically called a ramp. So you are fine even if you don't keep a delay. But if you want a good looking ramp, then keep a delay of 2, 3, 4 milliseconds. Have I made myself clear? So that is ramp. Program is the same. Just remove the delay and keep a small delay. Or replace it with a small delay. Next one, sawtooth. Gradually go on incrementing till FF. Suddenly drop to 0. Gradually go on incrementing to FF. Suddenly drop to 0. What is the change? Replace this J and Z back with S jump back. Put an unconditional jump over here. What does an unconditional jump do? It will make this an infinite loop. So what happens in an infinite loop? You took A register, which was 0, 0. You go on incrementing it. Any register when you go on incrementing it will gradually increment all the way up to FF. Any 8-bit register after FF automatically comes to 0. You have to do nothing. The program will do this by itself. All you have to do is replace this conditional jump with an unconditional jump, right? Let's jump back over here, and this line is not required. This will become an infinite loop. So what will happen? A will go on getting incremented all the way up to FF, suddenly drop to 0. Then gradually increment up to FF, drop to 0. That's your staircase waveform. Please tell me, did you understand? Again, keep a very small delay, otherwise it will look like this. It will look more spiky than a staircase. Are you clear? Just keep a delay. Keep a small delay, very small delay, but keep a delay so that you can see their slope. Lastly, triangular waveform. Now this is the reason why we are learning this whole video. This is the one that comes the most. Even those can come. I have seen papers, 18 years, it's a long time. I have seen every kind of question, but this comes the most. It came 2 days back in the EXTC paper of Bombay University. Day after tomorrow or 2 days from now is the Tronics paper. What was going to come? I don't know. But this is very important. Now, triangular waveform. Triangular waveform is gradually increment up to FF, gradually decrement up to 0. Again, gradually increment up to FF and gradually decrement up to 0. So I hope you understood. You will have 2 loops over here. One loop will go on incrementing, the other loop will go on decrementing. So as you can see, there is a loop that goes on incrementing and there is a loop that goes on decrementing. Now what is interesting to know is, your incrementing loop will go from 0, 0 to FF. Your decrementing loop will start from FE to 0, 1. Please tell me, did you understand this point? FE to 0, 1. Why? If you start this loop with FF, you will have 2 points at FF. So you have a blunt edge at the top. It's not like you will get a 0 for your whole program for doing that, but nobody will give you full marks because it is not technically a triangular waveform. It just looks bad. It's bad programming. Again, how can you display 0 twice? This loop should end at 0, 1 so that this loop takes over from 0, 0. So you have exact triangle without any blunt edges anywhere. Please tell me, do you understand? Come on. Now, your first loop, move A, has 0, 0. You start with 0, move B1, A. So you displayed 0, call a small delay, very small delay, otherwise it will be near vertical, it will look bad triangular waveform. So call a small delay, increment A. A was 0, it has become 1. J and Z. What is J and Z? Jump if not 0. Till the time A doesn't become 0, keep doing this. So A was 0, it became 1. You displayed 1, it became 2. You displayed 2, it became 3. You displayed FE, it became FF. You displayed FF, it became 0, loop will break because I've said jump if not 0. So this loop has done its job. It has displayed from 0, 0 to FF. Tell me, did you understand? Now your second loop will start. Your second loop will start with what value? FE. Move A, hash FE. Any number that begins with an alphabet should have a leading 0. Come on, if you come all the way up to here in 8051, you know these basics. If you don't put the 0, assembler will treat this to be a variable and will give you an error undefined variable because FE can be the name of variable. Anyway, so you put a 0. Now, move P1, A. What value is it outputting? FE. So it's starting from the very next position of your triangular waveform. After FF, it's starting from FE. So you display FE, A called DA, fine. Decrement A. So decrement A means A will become FD. Jump if not 0. FD is not 0. So it will jump back. Are you clear? Now, you display FD, A will become FC. You display FC, A will become FD. Blah blah blah. You display 0, 2, A will become 0, 1. You display 0, 1. A will become 0, 0. I have said jump if not 0, but A will become 0, 0. Loop will break. So what did you display? You displayed from FE to 0, 1. That is exactly what you wanted. Now, when this loop broke, A was 0, 0. Your next loop has to start displaying from 0, 0. So simply S jump back 1. This is back 1. You will directly start displaying from 0, 0 because move P1, A was 0. You will start displaying from 0, 0. So your first loop will go from 0, 0 to FF. Second loop will go from FE to 0, 1, 0, 0 to FF. That's a triangular waveform. Please tell me, is this difficult? People get petrified thinking triangular waveform. How do you create it? What is a triangular waveform? Go on incrementing the value, then go on decrementing the value. Please keep the same delay at both places. Otherwise, you'll get a waveform which will be between a staircase, between a sawtooth and a triangular waveform. Because this slope and this slope will be different. It won't be vertical, but it won't be exactly this slope. So you'll get a funny waveform. So just keep the same delay at both, or don't keep a delay. But don't keep different delays. It will become a mess of a program. Anyway, I hope you understood it. All the best.